In this session, we will discuss about shifted data problems. In the above problems, we solve the differential initial value problems with the initial conditions at some t equal to 0. That is, the initial conditions will be y of 0 equal to something and y dash of 0 equal to something. Initial conditions at some t equal to 0. If the initial conditions are given at some t equal to t naught, instead of t equal to 0, if it is t equal to t naught, in this case we take, let t is equal to t bar plus t naught. That means if we take the initial condition at t equal to t naught, means t minus t bar is equal to t minus t naught, therefore t bar equal to 0. Okay, so that means we shifted the function of t to function of t bar. Function of t to function of t bar using this relation t is equal to t bar plus t naught. That is, t bar is equal to t minus t naught. Using this relation, we shifted the function of t to function of t bar. That means the initial condition, initial value problems with the t equal to t naught to initial value problems with the t equal to 0. That is like our above problems. So using this transformation, we can shift the function of t to function of t bar, and then we can solve the differential equations using Laplace transforms. Consider the first problem. Solve y dash equal to, so y dash minus 6y equal to 0 with initial condition y of minus 1 equal to 4. Here, instead of y of 0 equal to some value, here instead of 0, that is, the initial condition is given at some point t naught minus 1. Okay, so here t naught is equal to minus 1. So first we use the transformation t bar is equal to t minus t naught. Using this transformation, we can shift the function of t. That is, here y is the function of t. We can shift the function of t to function of t bar. That is, the initial condition y of minus 1 becomes, when we change t to t bar, we can represent that function as y bar. Instead of y is a function of t, y bar is a function of t bar. So we change, using this transformation, we change function of t to function of t bar. That is, a notation is y bar. So the initial condition becomes y of minus 1 equal to 4 becomes y bar of 0 equal to 4. Okay. Therefore, the above equation y dash becomes y bar dash using this transformation. Here the t naught is minus 1, that is t minus minus 1, that is equal to t plus 1. Okay, using this relation, t bar is equal to t minus t naught, that is equal to t minus minus 1 is equal to t plus 1. Using this transformation, we can change the function of t to function of t bar. That is, function becomes y bar dash minus 6 into y bar is equal to 0. Then with the initial condition y of minus 1 equal to 4 becomes y bar of 0 equal to 4. Since using the transformation, it is y of t naught. Using the transformation, y becomes, applying the transformation, t bar is equal to t minus t naught. That is, y becomes y bar and minus 1 becomes, the initial conditions becomes at the point 0. Since at t equal to t naught, t minus t naught is 0. Therefore, t bar becomes 0 at the initial condition. That's why we write y of minus 1 becomes y bar of 0. Y bar of 0 equal to 4. Okay, then like in the above solution of differential equation, apply the Laplace transform on both sides. That is, L of y bar dash minus 6 into L of y bar is equal to L of 0. That is, what is L of y dash? L of y dash is equal to S into L of y, that is s into, that is we use instead of y Laplace transform of y, we use capital Y of s. Here we use Laplace transform of y as Laplace L of y itself. Therefore L of not y, y bar, s into L of y bar minus y of 0. Instead of y of 0 it is y bar of 0. This is our L of y bar dash. L of y bar dash minus 6 into L of y bar is equal to L of 0 is equal to 0. Then we take L of y bar outside. L of y bar into s minus 6. Then y bar of 0 is equal to 4. Therefore minus 4 is equal to 0. That is L of y bar is equal to, moving 4 to the left side, this becomes 4 divided by s minus 6. That is L of y bar. We have to find out y bar. For that we apply the inverse Laplace transform on both sides. Therefore becomes L inverse on both sides, we get L inverse of L of y bar becomes y bar. L inverse of right hand side is 4 divided by s minus 6. What is L inverse of 4 by s minus 6? That is equal to 4 into inverse Laplace transform of 1 by s minus a. It is a standard form, that is e raised to at. Here it is e raised to 6. A is 6. Actually it is e raised to 80, that is e raised to 60. But here the variable is t bar instead of t. Therefore we write it as e raised to 6 into t bar. That is equal to 4 into e raised to, therefore yes, is equal to y bar is equal to 4 into e raised to 6 t bar. Then we have to move back to the solution. Actually our solution is y. We got only y bar. So we have to change to y. What is y? To get y, replace t bar using this relation. T bar is equal to t plus 1. That is 4 into e raised to 6 into t bar is t plus 1. Therefore this is function of t. This is our solution.